Hey AP Physics 1, this is Mr. Heinrich. Welcome to my class unofficially. I know we're not going to meet for a little while. August 3rd looks like our start date for now. We'll see if that stays or that changes in the near future. But there are some problems in particular in your summer assignment that I know will be difficult, 17 and 19 in particular, but I want to start off doing number 13. So number 13 is a very manageable problem. It'll introduce us to the concepts of vector addition as well as the difference between displacement and distance. The textbook that we're using is College Physics by Serway and Vuille. Those are the authors, and it's the 10th edition. So let's get right into it. Number 13, a girl delivering newspapers covers her route by traveling 3 blocks west. I'm writing that down on my paper that you'll see in a second. 4 blocks north. And finally 6 blocks east. And they want us to figure out, part A, what's her resultant displacement, and B, what is the total distance she travels. And that was 6 blocks east. All right, so let's get to the paper here and give it a second to focus. That'll work. Okay. So when you're doing vector addition, there's some important concepts about vectors that I want you to read, and that reading has been included in your summer assignment, the pages, or rather the sections I want you to read and take notes on. So vectors have both magnitude and direction. That means we need to represent them as having a direction, hence we're going to use arrows, and they need to have a magnitude. Now when we're doing vector drawings, our magnitude can just be a length that we choose. However, the subsequent vectors that follow should be based upon that first vector length that we choose. So let me show you what I mean by that. Here we have 3 blocks west, and so I need to go 3 blocks to the left. If we're trying to represent north, south, east, west, we know that that's north, that's south, that's left is west, and right is east, right? So let's say that's 3 blocks, and you can put, I'm going to make it a little longer, you can put that designation right there. Now normally we're going to be working in meters or kilometers or meters per second, because vectors can also represent velocity or acceleration. There are many different vector quantities, but we're starting off with displacement vectors. So each one of these is a displacement. And so I might call that delta x1 equals that, delta x2. That just means a change in delta, a change in x position, a change in position 1, a change in position 2, a change in position 3, and I'm not going to keep saying a change in position. We'll call those displacements or delta x, right? And that's all in the reading. So we have 3 blocks west, and you're going to see I have an issue right away. Look, I'm going to go 4 blocks north, and I'm going to go off the paper. So that was not a good spot to start, right? So you might want to have that in mind when you're doing your drawings. Now you might say, is the drawing necessary? And the truth is, no, it's not. It's not necessary, but it helps us to visualize the physical situation. So there's 3 blocks to the west, and if that's 3 blocks, then I need to make 4 blocks longer, right? That would be 3 blocks roughly north, but I'm going to go a little further to represent, yeah, that's a longer vector, 4 blocks right there. That's delta x1, delta x2, and you're noticing something here. I'm putting these vectors head to tail. That is one of the ways that we can add vectors, and I hold that it's the most useful way to add vectors. So from the head of the last vector, you take the next vector and put its tail on the head of the previous one, and you go 4 blocks north. And now let's go 6 blocks. That would be 3. That would be 6 blocks to the right or east, right? Now, sometimes in class, you'll see me label this delta x1, delta x2, delta x3, because I've already got the key up here, my set of given information, right? But this works as well. Now, here's the thing. Displacement is not the total length that you travel. That is the distance. So I'm going to take a moment real quick to answer part B. Part B asks us for the distance. And that's as simple as adding all of these up. What do we got here? 10, 13. Done. 13 blocks is our distance. And I'll even put a capital D for distance. Or you can use a lowercase d. That's fine. So that's our distance, but A is the harder problem of the two. We have to find the displacement. Now displacement is a change in position. So I started here and I'm changing my position from here to here. So my actual total displacement, also called a resultant displacement or total displacement, that's why I put delta XR for resultant, is the change in position from my beginning to my ending point. And so there you go. That is the visual representation of the mathematical answer that I need. So, if you've already taken pre-calc or math 3 and you've done vector addition, I might do it slightly different than your teacher did it, but I really like to start with the visual because it gives us an idea. Hey, we're looking for a length that's looks a little more than 4, right? It's not quite 6, so it should be like 5-ish or something like that. And it gives us a good idea as long as our drawing was good to begin with. Notice also my resultant vector goes from the tail of my first vector to the head of my last vector. So when we're adding vectors, we put tails to heads, the tail of the next vector to the head of the previous vector. But when we're doing our final vector, our resultant goes from the tail of the first to the head of the last. All right, enough talking about that. Let's actually get to the math answer. Do you notice here how many blocks I actually went to the east when all was said and done? Isn't it just 3 blocks? And, we could show the math and show the work, but I think it's pretty safe to say we went 3 blocks to the east. That would be what I call the sum of my delta x's in the x direction. There's a lot of notation there. Sigma means sum of my displacements in the x-axis. And if we wanted to be formal about that and actually show the work, and I will since we haven't done a problem like this before, the sum of my delta x's or my displacements in the x-axis would be 6 blocks minus 3 blocks, which we know that's 3 blocks. But it's 3 blocks to the east. That's important to note, right? 3 blocks to the east. All right, and similarly, if I wanted to get super formal and write the sum of my displacements in the y-axis, the sum of my displacements in the y-axis is 4 blocks north plus minus nothing, right? There's only 4 blocks north. That's it. So if I wanted to be really formal, and you'll find that in class, I do, especially when it's a test, I do want you to show every step because it helps your point total also. It helps in the scoring, it helps in your organization of your work as well. But yeah, with the problem this basic, I understand. Look, it's 3 blocks to the east that we went and 4 blocks to the north, and that was our sum of our displacements in the y-axis, which, I already explained is that. Okay, now forget all of this stuff. Do you see that I have a new drawing here? What does this look like to you? Looks like a right triangle, and we can do Pythagorean Theorem to find that delta XR. So I'm going to write delta XR squared equals, I'm going to drop the unit here just to make things go a little easier, 3 squared plus 4 squared. And if I'm going to isolate, this is Pythagorean Theorem, right? A squared plus b squared equals c squared. A squared plus b squared equals c squared. And then I'm going to isolate delta XR by doing the inverse operation. 3 squared is 9 plus, well, look what's happening here. You might already know that this is a special triangle, that this is a 3, 4, 5, right? Because 9 plus 16, 25. That's my displacement in the, well, it's my resultant displacement, and we know the square root of 25 is, 5. There we go, blocks. Now, that is not a total answer in vector land, because I told you at the beginning of this video that vectors have magnitude and they have direction. So right now, we can't say this is north. We can't say this 5 blocks is east. It's a combination of both, and it's incorrect to say northeast because that's only true if this is a 45-degree angle. So if I want to find this angle here, that angle theta, I can do that pretty quickly with the tangent of theta. Use my tangent operation. Remember, tangent of an angle is opposite over adjacent, right? So the tangent of theta is this ratio of the sides of the opposite and the adjacent side of the triangle. And so if I do my inverse operation here, 4/3, get my calculator out real quick, it should be close to 53. Sure enough, it's 53.1. You know what? I'm going to go with 53 degrees. You're going to find out I'm not a big stickler for rounding. As long as it is a reasonable rounding, that's fine. So I'm going to say this is 5 blocks at 53 degrees, because you can clearly see that if I was to put a little xy axis here, right, little xy axis here, at the tail of my resultant vector, I'm indeed 53 degrees from the positive x-axis. So this is a good answer right here. We could also say, well, that's all the time I have. Talk to you soon.